Good evening, all of you. Today we are going to see the topic that is reflection of light at curved surfaces for 10th class English medium. Before going to start the chapter, first we have to know what are the curved surfaces. The curved surfaces are two types. One is concave and convex surfaces. Here you can see the concave surface and convex surface of the spoon. The bending inward surface is called as concave surface, and bending outward surface is called as convex surface. సో ఇక్కడ స్పూన్ ఇన్వర్డ్ అంటే లోపల ఏదైతే ఉందో అది కాన్కేవ్ సర్ఫేస్ అంటాము. అట్లనే స్పూన్ బయట వైపు ఏదైతే ఉందో సర్ఫేస్ దాన్ని మనం కాన్వెక్స్ సర్ఫేస్ అంటాం. ఇక్కడ మనం చూసినట్లయితే కాన్కేవ్ సర్ఫేస్ పైన తర్వాత కాన్వెక్స్ సర్ఫేస్ పైన మనకు ఇమేజ్ అనేది డిఫరెంట్గా కనిపిస్తుంది. యూ కెన్ సీ ద ఇమేజ్ that is different in concave as well as in convex. So the images are appearing differently in concave and convex. Okay, so these are all curved surfaces. So curved surfaces are generally two types, concave and convex surfaces. Here the spoon that is looking like a mirror. What mirror can do? Mirror reflects the light. Then only we can see the image on the mirror. Without a reflection of light, we cannot see our face on the mirror. So first of all, we see what is a reflection of light. So here the definition of reflection of light, here we can see in the slide, it is when a ray of light approaches a smooth polished surface and the light ray bounces back, it is called the reflection of light. So when light approaches a smooth polished surface, so here when you see any mirror, you can see two surfaces. One is polished smooth surface, and back side of that surface is coated surface. So when light incident, that means when light falls on the smooth polished surface, the light get back, that is called as reflection of light. Bounces back means getting back, that is called as reflection of light. Here what is getting back? The light ray that is getting back, that's why it's a reflection of light. Then we know the laws of reflection of light that already we studied in previous classes. A light ray incident at an angle with the normal at the point of incidence will get reflected making equal angle with the normal. So that means the angle of incidence is equal to angle of reflection. ఎంత angle తోనైతే అది ఫాలో అవుతుందో, సో ఫాలో అయ్యే ఆ పాయింట్ అక్కడ నార్మల్ మనం డ్రా చేసినట్లయితే, అంటే ఒక పెర్పెండిక్యులర్ను డ్రా చేసినట్లయితే అక్కడ ఎంత యాంగిల్ అయితే ఫామ్ చేస్తుందో దాన్ని మనం యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ అంటాం. సో ఎంత యాంగిల్తో అది ఇన్సిడెంట్ అవుతుందో అంత యాంగిల్తోనే అది రిఫ్లెక్ట్ అవుతుంది. సో ఆ నార్మల్ పాయింట్ దగ్గర మనము యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ను, తర్వాత యాంగిల్ ఆఫ్ రిఫ్లెక్షన్ మనం చూసినట్లయితే we see both angles are same. So the angle of incidence is equal to angle of reflection. Then in next slide, now we see finding normal to curved surface. For this we use foam and pins. So take a plain foam surface and fix the nails on the foam surface like this. So here the pins which are at different points. So this represents that the normals of plane surface which are at different points. But when we bend this foam inward like this, like in figure 2, so here the pins which are converging at a point, that means when we bend inward the plane foam, all the pins are converging at a point. This is called as center of curvature. And when we bend this foam outward, the pins are diverging, they are moving away from each other. So here By doing this activity, we can say the bending surfaces, that means the curved surfaces which have the center of curvature. Now we see the important things of concave and convex mirrors. The center of the spherical mirror, which is the part of the sphere, is called center of curvature. This is denoted by capital letter C. For both mirrors, concave and convex, you can see the center of curvature. For concave and convex mirrors, we see the center of curvature. The midpoint of the mirror is called pole of the mirror. This is denoted by capital letter P. In two figures, in two mirrors, you can see the midpoint of the mirror, that is denoted by capital letter P. The horizontal line which passes through the center of curvature and pole is called principal axis of the mirror. The line that is passing through center of curvature and pole, that is called as principal axis. In two figures you can see the principal axis. The distance between pole of the mirror and center of curvature, that is called as radius of curvature, that is denoted by capital letter R. Now we see the activity to show parallel rays of light. In this activity, we see how we get parallel rays of light. When the source of light that is near to the object, we see the light rays, they are diverging from each other. When the source of light is far away, that means when the distance between the object and the source of the light is more, you can see the rays which are parallel to each other. So here for this activity we do what? We take the wooden block or thermocol block and we fix two pins parallel to each other on the thermocol block, and we put the source of light, that means candle, near to the thermocol block in first case. Then we see the image of two pins, that means the shadow of the two pins. By observing keenly the pin's shadow, we can see the two pins shadow, the image of the two pins, they are diverging to each other. But when we make certain distance between the thermocol block and the source of light, we see the shadow of two pins. We see the image of the two pins and we observe the two pins image, they are parallel to each other. That means the rays which are coming from the pins which are parallel to each other. సో ఇక్కడ ఏమవుతుందంటే, ఇక్కడ ఆ సోర్స్ ఆఫ్ లైట్ క్యాండిల్ను థర్మోకోల్ బ్లాక్ దగ్గర పెట్టినప్పుడు అక్కడ టూ పిన్స్ డైవర్జ్ అవుతాయి. ఆ ఇమేజ్ చూసినట్లయితే ఆ టూ పిన్స్ ఇమేజ్ ఇక్కడ ఈ టూ పిన్స్ డైవర్జింగ్ అవుతున్నాయి, అంటే ఒకదాని నుంచి ఇంకొకటి దూరంగా వెళ్ళిపోతున్నాయి. బట్ ఇక్కడ ఈ థర్మోకోల్ బ్లాక్ అండ్ క్యాండిల్ మధ్యన డిస్టెన్స్ని మనం పెంచుతున్న కొద్ది ఏమవుతుంది అంటే ఆ డైవర్జెన్స్ యాంగిల్ అనేటిది, యాంగిల్ ఆఫ్ డైవర్జెన్స్ అనేటిది రెడ్యూస్ అవుతుంది. సో దూరంగా వెళ్ళిపోయేటి కాస్త దగ్గరగా వస్తాయి. సో అక్కడ మనకి ఏం జరుగుతుంది అంటే సర్టెన్ డిస్టెన్స్ ఉన్నప్పుడు, అంటే ఇక్కడ థర్మోకోల్ బ్లాక్ అండ్ క్యాండిల్ మధ్యన డిస్టెన్స్ మోర్ ఉన్నప్పుడు, అంటే ఫార్ డిస్టెన్స్ ఉన్నప్పుడు ఇక్కడ ఆ డైవర్జెన్స్ యాంగిల్ అనేది రెడ్యూస్ అయ్యి ఆ టూ పిన్స్ ప్యారలల్ టు ఈచ్ అదర్గా రావడం జరుగుతుంది. అంటే ప్యారలల్ రేస్ ఆఫ్ లైట్ ఉండాలి అంటే సోర్స్ ఆఫ్ లైట్ అనేటిది ఫార్ డిస్టెన్స్లో ఉండాలని తెలుస్తుంది. సో ద source, when the source of light is at far distance, we see the parallel rays coming from the source of light. Now we are going to see how to find the focus or focal point. So here we see in this figure the parallel rays which are coming from the sun, they incident on the concave mirror. After reflection, the reflector rays are converging at a point. So this converging point is called as focus or focal point, and we denote this focus or focal point with capital letter F. The distance between pole and focus is called focal length of the mirror, and we denote with a small letter f, and the radius of curvature will be twice the focal length of the mirror. So that's why we write capital letter R is equal to 2f. For convex mirror also there will be focus or focal point. So here we see in this diagram the parallel rays coming from the sun appear to diverge after reflection. If we extend the reflector rays backwards, they meet at focus, that is focus of the convex mirror. Now we see lab activity. Aim of lab activity: observing the types of images and measuring the object distance and image distance from the mirror. Material required: a candle, paper, concave mirror, known focal length, that means 20 centimeters or 30 centimeters. We stand, measuring tape or meter scale axis. Procedure: place the concave mirror on V stand, arrange a candle and meter scale as shown in figure. Keep the candle at different distances from the mirror. It would be from 10 centimeters to 80 centimeters along the axis, and by moving the paper, find the position where you get the sharp image on paper. Take care that flame is above the axis of mirror, paper is below the axis. So first కాన్కేవ్ మిర్రర్ను వీ స్టాండ్కి ఫిక్స్ చేసిన తర్వాత ఈ మిర్రర్ బిఫోర్ మనము ఈ మీటర్ స్కేల్ను క్యాండిల్ ఉంచేసేయాలి. తర్వాత ఒక వైట్ పేపర్ను తీసుకొని, అది మనకు స్క్రీన్ లాగా పనిచేస్తుంది. మిర్రర్ ముందు మనము పేపర్ను అడ్జస్ట్ చేస్తుండాలి. సో ఏ పొజిషన్ దగ్గర, ఏ డిస్టెన్స్ దగ్గరనైతే మనకు షార్ప్ ఇమేజ్ కనిపిస్తుందో అక్కడ ఆ స్క్రీన్ అలాగే ఉంచేసి మనం ఇప్పుడు మిర్రర్ నుంచి ఈ క్యాండిల్ మధ్య డిస్టెన్స్ను, అంటే ఆబ్జెక్ట్ డిస్టెన్స్ను, అట్లనే మిర్రర్ నుంచి ఈ షార్ప్ ఇమేజ్ ఎక్కడైతే వచ్చిందో అక్కడికి మనము ఈ ఇమేజ్ డిస్టెన్స్ని మనము మెజర్ చేయాలి. సో ఇక్కడ మనకు ఆబ్జెక్ట్ డిస్టెన్స్ తర్వాత ఇమేజ్ డిస్టెన్స్ రెండు వస్తాయి. నోట్ డౌన్ ద వాల్యూస్ ఇన్ ద బిలో టేబుల్. సో ఇక్కడ మనము ఈ డిస్టెన్సెస్ను మెజర్ చేసిన తర్వాత మనము వాల్యూస్ని బిలో టేబుల్లో మనము నోట్ డౌన్ చేసుకోవాలి. Now we see the table. Here in first case, the distance of candle from mirror, that means object distance. Object distance we always denote with a small letter u. I got here 30 centimeters. And distance of paper from mirror, that is image distance. Image distance we always denote with a small letter v. Here I got 60 centimeters. And the nature of the image, it is enlarged and inverted. Enlarged అంటే ఆబ్జెక్ట్ సైజ్ కంటే బిగ్ సైజ్, అండ్ ఇన్వర్టెడ్ అంటే తలక్రిందులుగా అన్నట్టు. నెక్స్ట్ సెకండ్ కేస్లో, ఇన్ సెకండ్ కేస్ ఐ గాట్ ఆబ్జెక్ట్ డిస్టెన్స్, దట్ ఈస్ u, it is 60 centimeters, and image distance v is equal to 30 centimeters. In this case the nature of the image, it is diminished and inverted. Diminished అంటే ఆబ్జెక్ట్ సైజ్ కంటే ఇమేజ్ సైజ్ తక్కువగా ఉండడము, అండ్ ఇన్వర్టెడ్ అంటే తలక్రిందులుగా ఉండడం. And here we can take more object distances. So for more object distances we can get more image distances, and we observe the nature of the image also different. Now we see at a different position of the object, we see position of the image different, and the nature of the image also differently. So in first case, when the object is between mirror and focal point, the position of the image behind the mirror and nature of the image enlarged, erect, virtual. Virtual means we cannot capture on the screen, we only see on the mirror. Next, in second case, when the object on focal point, we get the image at infinity. So here we cannot see the image because it is at far distance, so that's why we say at infinity. We cannot observe the nature of the image because the image that is at infinity. In third case, when we place the object between focal point and center of curvature, position of the image beyond center of curvature, and that is enlarged, inverted, and real image. Real image means we can capture on the screen. And in fourth case, when we place the object on center of curvature, we get the image on center of curvature, and the nature of the image same size of the object and inverted and a real image. And in fourth case, when we place the object beyond the center of curvature, the position of the image between focal point and center curvature, and nature of the image diminished, inverted, real. And in sixth case, when we place the object at infinity, we get the image at focus, and nature of the image point size very small, so we cannot say that is inverted or erect because that is point size, and real image because we can capture on the screen. So here the image formation diagram we are seeing here. So at a different object distances, we can get different image distances, and we can also observe the nature of the image differently. Here we see the ray diagram for concave mirror. This diagram shows two rays coming from the tip of the flame. The reflector rays are constructed based on the laws of reflection. They meet at point A. The tip of the flame of the reflected image will be at the point of intersection A. So ikkada two incident rays after falling, they are reflected and they are meeting at point A. So A point దగ్గర two reflector rays converge అవుతున్నాయి. సో ఆ ఇంటర్సెక్షన్ పాయింట్ ఏ దగ్గర షార్ప్ ఇమేజ్ అనేది ఫామ్ అవుతుంది. To better understand about ray diagrams, first of all we have to know the character of incident ray. Rays that are parallel to the axis get reflected such that they pass through the focal point of the mirror. So here the incident ray that is parallel to the principal axis, after reflection the reflector ray that is passing through focal point or focus. To make it more convenient, we will always take rays that come from the tip of the object. సో మనం రే డయాగ్రామ్ను కన్వీనియంట్గా డ్రా చేసుకోవడానికి ఆల్వేస్ రేస్ను మనము ఈ టిప్ ఆఫ్ ద ఆబ్జెక్ట్ నుంచే మనం డ్రా చేస్తాం. టిప్ ఆఫ్ ద ఆబ్జెక్ట్ అంటే ఆబ్జెక్ట్ యొక్క కొన అన్నట్టు. Ray coming from the tip of the flame and going through the focal point and falling on the mirror. After reflection, this ray travels parallel to the axis. So here the ray that is passing through focal point and falling on the concave mirror, and it is reflected and it is passing parallel to the axis. సో ఫోకల్ పాయింట్ నుంచి పాస్ అవుతూ ఇన్సిడెంట్ అయినటువంటి రే రిఫ్లెక్షన్ తర్వాత ప్రిన్సిపల్ యాక్సిస్కు ప్యారలల్గా ట్రావెల్ చేస్తుంది. Here ray coming from the tip of the object going through the center of curvature to meet the mirror, it will get reflected along the same line. The incident ray that is passing through center of curvature, after reflection the reflector ray that is also passing through center of curvature. సెంటర్ ఆఫ్ కర్వేచర్ నుంచి పాస్ అవుతున్నటువంటి ఇన్సిడెంట్ రే రిఫ్లెక్షన్ తర్వాత ఆ రిఫ్లెక్టర్ రే సెంటర్ ఆఫ్ కర్వేచర్ నుంచే పాస్ అవుతుంది.
The position and nature of image, formed by a concave mirror, depends upon the position of object. There may be 6 positions of the object. So, 2 points remember. The intersection of 2 reflected rays gives the position of image. The position, size and nature of image formed by concave mirror depends upon the position of object. First case. When the object is at infinity. The rays coming from the object, placed at infinity, are parallel to the principal axis, which passes through the focus after reflection. And the point, where 2 or more reflected rays meet, is called the focus. So, the image is formed at focus. Since the image is formed by actual meeting of the reflected rays, thus the image formed is real. The size of image is much smaller than the object, so we say, the image is highly diminished. Second. When the object is placed beyond center of curvature. Here is an object AB, placed perpendicular to principal axis, beyond center of curvature. A ray of light from point A goes parallel to principal axis. This will pass through focus after reflection from the mirror. Another ray of light we are taking is incident on the mirror. After passing through focus, this will be reflected parallel to the principal axis. The meeting point of 2 reflected rays will be the image of point A. We termed as a dash. Now, we draw a perpendicular ray as B dash that is perpendicular to principal axis of the mirror. So, here's what we can say about image. The image is formed between focus and center of curvature of the mirror. The image is real and inverted. And it is smaller than the object, so we say the image is diminished. Third case, when the object is placed at center of curvature. So again we take an object AB placed perpendicular to principal axis, at the center of curvature. A ray of light from point A goes parallel to the principal axis. This will pass through focus after reflection from the mirror. Another ray of light we are taking is incident on the mirror, after passing through focus. This will be reflected parallel to the principal axis. The meeting point of 2 reflected rays will gives us the image of point A. We term it as A dash. Now, we draw a perpendicular A dash B dash to the principal axis of the mirror. This is our required image. So, here's what we can say about image. The image is formed at center of curvature. The image is real and inverted. And it is of same size as the object. Now, fourth case. When object is placed between center of curvature and focus. Now the same object, basically we are having here. AB, placed perpendicular to principal axis. A ray of light from point A goes parallel to the principal axis. This will pass through focus after reflection from the mirror. Another ray of light we are taking is incident on the mirror after passing through focus, as the case of previous. So this will pass, or say this will be reflected parallel to the principal axis. The meeting point of 2 reflected rays will give us the image of point A. We term it as A dash, and we draw a perpendicular A dash B dash to the principal axis of the mirror. So this is our image. So here's what we can say about image. The image is formed beyond center of curvature. The image is real and inverted. And the image is magnified. Fifth case. Now the same object is kept at focus. A ray of light parallel to principal axis will pass through focus after reflection from the mirror. Another ray of light, falling on pole, will get reflected, following the laws of reflection, as we have seen in the rules for image formation. Now the 2 rays are parallel to each other, and would intersect at infinity. So we say, this image is formed at infinity, and it is highly magnified. Sixth case. When the object is placed between pole and focus of concave mirror. Let's start the image formation. A ray passing through center of curvature retrace its path. So, the direct ray of light that is along a center of curvature, so this will retrace its path. Another ray passing through pole will get reflected obliquely, making equal angles of incidence and reflection with the principal axis. The two rays are divergent and cannot meet actually. But, if we produce them back, they appear to come from point A dash. Now we draw perpendicular A dash B dash perpendicular to principal axis of the mirror, thus A dash B dash is the virtual image of object, AB. So, the image is formed behind the mirror. It is virtual and direct. And it is magnified.
Same rules for convex mirrors for ray diagrams. In first case, when the incident ray parallel to the principal axis, the reflected ray appears to coming from the focal point. In second case, when the incident ray coming towards the focal point, the reflected ray will be parallel to the principal axis. In third case, when the incident ray coming towards the center of curvature, the reflected ray appears to coming from the center of curvature. Here we see image formation by convex mirror. Image cannot be caught on screen and visible only in the mirror. Hence, this is virtual image. Image always diminished and erected. Here we see two incident rays falling on the convex mirror. One is parallel to the principal axis and another is coming towards the center of curvature. After reflection, we extend the reflected rays backwards and they are meeting at a point. So, at a meeting point of reflection, we get the image. So, here AB, that is object, and A dash B dash, that is image. So, here we see the image that is erected and diminished. Here we see mirror formula. Mirror formula we use to find the focal length of the mirror and also to find object distance or to find image distance. Mirror formula we write as 1 by f is equal to 1 by u plus 1 by v. F, that is focal length, u object distance, v image distance. Sign convention, that is plus or minus, for the parameters related to the mirror equation. ఇక్కడ మిర్రర్ ఈక్వేషన్లో ఉండే పారామీటర్స్ అంటే ఒక లెంత్ స్మాల్ ఎఫ్, ఆబ్జెక్ట్ డిస్టెన్స్ స్మాల్ యూ, ఇమేజ్ డిస్టెన్స్ స్మాల్ యూ. సో వీటిని మనము మెజర్ చేసేటప్పుడు సైన్ కన్వెన్షన్ను మనము దృష్టిలో పెట్టుకోవాలి. ఆల్ డిస్టెన్సెస్ షుడ్ బి మెజర్డ్ ఫ్రమ్ ద పోల్. ఈ డిస్టెన్సెస్ ఏవైతే ఉన్నాయో ఫోకల్ లెంత్, ఆబ్జెక్ట్ డిస్టెన్స్, ఇమేజ్ డిస్టెన్స్, వీటిని మనము పోల్ ఆఫ్ ద మిర్రర్ నుంచే మెజర్ చేయాలి. The distances measured in the direction of incident light to be taken positive and those measured in the direction opposite to incident light to be taken negative. Incident light డైరెక్షన్లోనే మనము ఈ డిస్టెన్సెస్ను మెజర్ చేసినట్లయితే పాజిటివ్గా తీసుకోవాలి, అంటే ప్లస్గా తీసుకోవాలి. ఇన్సిడెంట్ లైట్కు ఆపోజిట్ డైరెక్షన్లో మెజర్ చేసినట్లయితే మనము ఈ వాల్యూస్ను నెగిటివ్గా తీసుకోవాలి, అంటే మైనస్లో తీసుకోవాలి. Height of object HO and height of image HI are positive if measured upwards from the axis and negative if measured downwards. Height of the object to height of the image ఒకవేళ ప్రిన్సిపల్ యాక్సిస్కు అప్వర్డ్స్ కనుక ఉన్నట్లయితే, పైన ఉన్నట్లయితే పాజిటివ్గా తీసుకోవాలి, ప్లస్గా తీసుకోవాలి. అదే ప్రిన్సిపల్ యాక్సిస్కు బిలో ఉన్నట్లయితే మనము నెగిటివ్గా తీసుకోవాలి, అంటే మైనస్గా తీసుకోవాలి. Now we see magnification of the mirror. Magnification of the mirror formula we write as m is equal to hi by ho, that is also equal to minus v by u. So here hi by ho, that is magnification, that means height of the image by height of the object, the ratio of height of the image and height of the object, or that is also equal to minus image distance by object distance. Suppose the height of the object, that is 10 centimeters. Suppose we got the image height, that is 5 centimeters. Then the magnification of the mirror is equal to hi by ho, that is equal to minus 5. Why we are writing minus 5? Because the height of the image, that is downwards, so that's why we write minus 5 by ho, we write as 10 plus 10. Why plus 10? Because that is above the principal axis. So minus 5 by 10, so that is minus 1 by 2, that is equal to minus 0.5. So here we see the magnification, that is 0.5. We know that Archimedes has burnt the ships by putting them at focal point. Concave mirror focuses parallel sun rays at the focal point of the mirror. So with a small concave mirror, we can heat up and burn paper. By using this technique, we can make solar cooker. For this, make a wooden or iron frame in the shape of TV dish. Cut acrylic mirror sheets into 8 or 12 pieces in the shape of isosceles triangles with a height equal to the radius of your dish antenna. The bases of 8 or 12 triangles together make the circumference of the dish. Stick the triangle mirrors to dish as shown in figure. సోలార్ కుక్కర్ను మనం తయారు చేసుకోవాలంటే ముందుగా మనము టీవీ డిష్ యాంటీనా ఫ్రేమ్ను వుడ్తో కానీ ఐరన్తో కానీ తయారు చేసుకోవాలి. తర్వాత 8 or 12 పీసెస్ ఆఫ్ అక్రిలిక్ మిర్రర్ను మనము కట్ చేసుకోవాలి. ఐసోసెలస్ ట్రయాంగిల్ షేప్లో కట్ చేసుకోవాలి. తర్వాత ఈ 8 or 12 ట్రయాంగిల్స్ని మనము ఒక దగ్గరగా పెట్టినప్పుడు అక్కడ మనకు ఒక సర్కంఫరెన్స్ ఆఫ్ ద డిష్ అనేటిది ఫామ్ అవుతుంది. సో ఈ ఏదైతే సర్కంఫరెన్స్ ఆఫ్ ద డిష్కి ఏదైతే ఫామ్ అయిందో ఇది మనకు కాన్కేవ్ మిర్రర్ లాగా పనిచేస్తుంది. సో దీని ముందు మనము వెజల్ పెట్టినట్లయితే, ఫోకల్ పాయింట్ దగ్గర వెజల్ పెట్టినట్లయితే ఆ వెజల్ అనేటిది హీట్ అవుతుంది. యూజెస్ ఆఫ్ స్పెరికల్ మిర్రర్స్. Uses of concave mirrors. We use concave mirrors in shaving or makeup mirrors. We use concave mirrors in dental mirrors. We use concave mirrors in car headlight mirrors. Uses of convex mirrors. We use convex mirrors in rear view mirrors for vehicles. We use convex mirrors in shop security mirrors. Now we see the difference between real image and virtual image. The image found by actual intersection of reflection rays is called real image. The image found by controlled rays of reflection is called virtual image. This can be caught on screen. It can not be caught on screen.